In this lecture, I'd like to look at the motion of electrons. Now, any moving charge has the ability to do work. And that means because electrons have charge, moving electrons also have the ability to do work. And that's exactly right. Because we saw that in electrochemical cells or batteries, when our electrons move from our anode to our cathode, they create electrical work. And this electrical work can be used to power a motor or to power a flashlight. Now, whenever electrons move per some given amount of time, that's called current. And current is represented with the capital letter I. It has the unit amperes or A. Now, amperes are simply coulomb per second, so charge per some given amount of time. So suppose we have this tube and we have electrons moving from the negative charge to the positive charge, or from the anode to our cathode. Now these electrons are moving, and that means if we want to find our current of these electrons, we simply take the amount of charge in these electrons and divide it by the time that it takes them to travel from this point to this point. And that is our current. It has the units coulomb per second, or simply amperes with the capital letter A. Now, unfortunately, when scientists came up with the idea of the current, they misrepresented it. And they said that current is the movement of positively charged species. And that means a current moves from the positive end, away from positive, to the negative end. When in reality, current is the movement of electrons, so that means the current should be going from negative to positive. However, they never changed that. And so now we're stuck with this inconvenient convention that even though electrons are moving from negative to positive, our current moves from positive to negative. But don't forget that this is actually misrepresented. That current is actually the movement of electrons. Even though current is said to flow opposite to the movement of electrons, current is still movement of electrons. It has the same magnitude, but just different sign. Now, let's look at part B. Let's look at the following picture. Suppose we have a solid object, so from some material. And suppose we look at the atoms that this solid object is composed of. It's composed of the same atoms, so it's a pure solid. Now, these are my protons, and the electrons are around. So electron shells and positively charged nuclei. So I have 8 of them. Suppose I make a hole on this side and this side, and I allow an electron to flow through my solid. What will dictate the speed or the ability with which my electron will be able to move from this point to this point? Well, if my atoms are pulling very hard on that electron, in other words, if my atoms want to gain electrons, if my atoms have strong affinity for electrons, that means my electron will not be able to move all the way to this end. In fact, when it enters, it's going to be pulled by those nuclei, by those atoms, by those protons, because if those atoms have a high effective nuclear charge, in other words, they pull those electrons strongly, then my electron will not be able to pass easily. On the other hand, if my material is composed of atoms that has a very low effective nuclear charge, or that does not want to gain electrons, that loses electrons very easily, that means this electron, when it will be passing through, it will not be attracted to my atoms very easily, and it will be able to pass through my material. So, the ability of electrons to move through some material depends on how strongly the atoms attract electrons to their nuclei. It depends on the effective nuclear charge. Now, another name for the ability of electrons to pass some given substance is known as conduction. Now, some substances are good conductors, while other substances are bad conductors. So metals, for the most part, are good conductors because their atoms, the protons found in their nuclei, will not attract electrons with a very strong force. because metal atoms have a very low or a relatively low effective nuclear charge, they will not attract those electrons, and the electrons will be able to pass freely from one point to the next. And that's exactly why solid metals, such as alkali metals or alkaline earth metals, have a sea of electrons within their material. That's because those electrons are considered to move freely. Now, nonmetals are poor conductors for the opposite reason. Their protons found in their nuclei have very strong attraction forces. They will want to pull those electrons away because they have a relatively high effective nuclear charge. And so our electrons will not be able to pass freely from one point to the next because these atoms will want to take in those electrons. Now note that every single material creates some resistance to electron flow. Now we're excluding superconductors. We'll talk about superconductors in a different lecture. But for now, we can consider that every material creates resistance. And that's because every material is composed of atoms. And even metals, even the metallic atoms, will attract our electrons to some degree.